Thanks, Jeremy. Hello, everyone. I'm grateful for this opportunity to be able to share an update on our snowplow preemption here in Utah. In this presentation, I'll give a quick overview of how this technology works in our UDOT snowplows, some benefits that we're getting out of it, where we have this technology deployed here in the state. And at the end, I'd like to update you on where we're headed with some of our future deployments, especially one of our projects that we're actively working on right now. Next slide. Thank you. UDOT utilizes V2X, or vehicle to everything technology, to provide green lights at traffic signals for snowplows. By leveraging this technology, snowplows that are actively plowing can request signal preemption from an upcoming traffic signal. On this slide over on the right, I'm showing one of our RSUs, or roadside units. We typically install these up on the vertical luminaire extension of a traffic signal mast arm. At each signalized intersection where we've deployed this technology, we set up a map message, which is basically a geofenced area around the intersection. We usually set it up to get about 1,000 feet on each leg of the intersection. So when a snowplow equipped with this V2X technology enters that mapped geofence, and as long as the salt spreader is active on it, the snowplow can put in a request message to the signal. The RSU picks up the message, runs it through a signal command module in the traffic signal cabinet. It talks to the signal controller, gets preemption granted, light turns green, and it also sends that message back to the snowplow. Next slide. On the roof of the snowplow, so pictured on the left, is the antenna. Next slide. That, one previous. Thank you. So that antenna runs down a cable into the truck. So this is a couple pictures here behind the driver's seat. So this slide shows two different setups that we've implemented on our snowplows. On the left, you see the OBU, which acts as a radio to communicate with the RSU at the traffic signal. And it's connected to the OBP, the onboard processor. The OBP is the brain of the unit, generating various types of V2X messages. And for this application on a snowplow, it's generating a signal request message to ask for preemption at the signal. The picture on the right is a brand of OBUs that we use that it doesn't require the OBP and can do the generating of messages itself. In both cases, this V2X onboarding equipment is hardwired to the snowplow salt spreader, like I mentioned before, so that it knows that when it's turned on or off. In Utah, we have more of the OBU with OBP setup deployed on our snowplows, and we felt like this would help us have more of an agnostic device to work with different OBU vendors. This also kind of stems from back when we were using DSRC radios. Now we've updated all those to CV2X radios around the state. So we mainly use that one on the left side that you see there. Next slide. So this technology allows plowing operations to be more efficient, removing the snow and ice from our roadways sooner. A study conducted by UDOT in 2018 on 5 urban corridors concluded that there are up to 89 crashes each year that occur when these roads are snowy, icy, or slushy. Also in 2018, we did a study where we tried to get measurements on the impacts and the effectiveness of our snowplows. We realized that this is really hard to measure, and we're still kind of evaluating that as time has gone on. The findings out of that study were kind of essentially inconclusive, and there's various reasons for that. I think what we realized is that we didn't really have good before and after data. Each route, each corridor that you analyze is different, so if you try to compare those corridor to corridor, it's difficult. Also, every storm to storm to storm is different, and so there's a lot of variances there that kind of led us to not really have a solid conclusion. But within the study, what we did get out of it is something that we often bring up, and that's we got some positive anecdotal feedback. Um, we had a season where we had some particularly heavy snowfall, and for whatever reason, I think our system it was down, and that snowplow driver contacted the region and basically said, "Hey, I noticed when your system isn't working. Uh, one of my corridors that takes me, an hour and a half to complete without the system. Well, I basically said when the system's working, I can complete my corridor in 45 minutes as opposed to an hour and a half when it's not working. Um, and that's a big deal for us. We were um, that tells us that there's quite a lot of value in that. Again, it's hearsay from a snowplow driver. Maybe he was exaggerating a little bit, but um, we've you know we can see that this really could reduce crashes caused by winter conditions around the state. And it's intuitive, right? If you can have a snowplow go straight on through an intersection without having to stop, it's able to remove the snow more effectively. It can throw the snow better, can throw the salt better. It's not having to start and stop. And if we're plowing and removing snow from the icy roads at a quicker pace, then that's better for all of our motorists traveling on the roadways. Next slide. We have this technology deployed on 12 corridors in Salt Lake County and Utah County. These are our most urban areas in the state that run along the Wasatch Front. We have 89 snow plows equipped with V2X technology. In addition to these corridors, UDOT plans to deploy this technology on a few more routes. You can see pictured on the right side image with the dash lines. This really is just a matter of getting some more roadside units deployed at these various signalized intersections, getting those locations configured with that map, that geofence I was talking about, and some V2X integration that needs to take place. Next slide. I wanted to give a quick snapshot of some of our numbers of where we're at with V2X deployment around the state. I also want to mention that this V2X ecosystem that we're building as part of our infrastructure has the long-term goal of safety. That's saving lives, preventing crashes. We believe that this is what we can achieve with V2X connected vehicle technology. And as we aim to achieve that, we get some neat use cases and benefits in the short term out of the system. So immediately we're enjoying the ability to have snowplow and emergency vehicle preemption. We get transit signal priority for our buses. This helps keep our buses on schedule, requesting some extra green time from the traffic signal if it's running late. We have curve speed warning applications, spot weather impact warnings, variable speed limits, and warnings to help protect our vulnerable road users like pedestrians and cyclists. So we have about 559 RSUs currently, with another couple hundred planned on being installed right now. We have those up and running within the next. We'll have those up and running within the next couple of months. Most of these RSUs are on state-owned signals. Some are on city signals. We have 284 equipped vehicles with OBUs, onboard units. This includes fleet vehicles, so our DOT's work trucks and some passenger cars, as well as our snow plows, transit vehicles, for instance, UTA, the Utah Transit Authority buses, um, and emergency vehicles. So we've got some ambulances and fire trucks equipped with this. Next slide. I'd like to give just a quick look ahead of some of the exciting things that we're working on right now. This past summer, UDOT was awarded a US DOT grant as part of their initiative to accelerate V2X deployment and interoperability nationwide. We named our program Connecting the West. We assembled a team of partnerships with CDOT, YDOT, City and County of Denver, General Motors, and ITS America. This program allows us to really expand what we're already doing with V2X deployment in each of our states. But a key piece of it is to collaborate and to make our system interoperable across state lines. Within the project, we plan to equip another 450 signalized intersections in Utah with RSUs. We'll install another 300 along the interstates in Utah and Colorado. I realize the maps pictured on the right are quite small, but what I want to highlight is the 1,400-mile rectangular loop with I-80 from Salt Lake to Cheyenne, and then I-25 down to Denver, I-70 to I-15. That takes us back to Utah, back up to Salt Lake Valley. Um, we'll have RSUs installed along that span, allowing us to send out various V2X messaging to equipped vehicles. We'll install 215 more OBUs on buses, snowplows, and fleet vehicles. We'll have a VRU warning application using LiDAR at 20 locations in Utah. We've defined 41 different traveler information messages, so the TIMs, that will be harmonized and interoperable between the 3 states. These are messages like curb speed warnings, weather impacts, snowy or icy conditions, things like that, which we can generate and send out to motorists. We'll also conduct a lot of rigorous validation testing. With GM, we're procuring a test vehicle equipped with all the bells and whistles and applications to run around and ensure our system is functioning the way we need it to. Next slide. So in closing, just want to kind of reiterate and highlight that improving safety, mobility, and operations effectiveness, as well as advancing technology solutions, are the fundamental goals of this Connecting the West program. Specifically, the goals are to use interoperable V2X technologies to reduce the number of crashes and fatalities at intersections and work zones, along rural corridors, in bad weather, and those involving VRUs. And it's to use interoperable V2X technologies to improve system operations and effectiveness in transit, emergency, and snowplow fleet vehicles to improve traveler mobility, improve safety, and reduce impacts on the environment. So a lot of great things happening right now. We're learning a lot, and we're excited to move this technology forward. So appreciate your time. Thank you. And back to you, Jeremy.